Hi, I am Anita Srinivasan. Today we saw some glossaries in digital electronics. First one, alphanumeric codes. The codes which consist of both numbers and alphabetic characters are called alphanumeric codes. The next, analog system. In analog systems, the output can be continuously controlled by the input and the output is linearly proportional to the input. Next one, AND gate. The AND gate performs logical multiplication, more commonly known as the AND function. Next one, arithmetic logic unit. It is a combinational logic circuit that performs arithmetic and logical operations such as addition, subtraction, and or complement as per the function select inputs. The next one, associative laws. This law states that in the ORing of several variables, the result is the same regardless of the grouping of the variables. That is, A plus B plus C is equal to A plus B plus C. Similarly, the law is AB into C is equal to A into BC. The associative law of multiplication states that it makes no difference in what order the variables are grouped when and several variables. The next one, asynchronous inputs. In flip-flops available in IC packages sometimes provide special inputs for setting or clearing the flip-flop. These inputs are called asynchronous or direct inputs. Next one, asynchronous sequential circuits. In asynchronous sequential circuit, change in input signals can affect memory element at any instant of time. Next one, base. It is the number of characters in the character set of position number system. It is also known as radix. Decimal numbers have base of 10, whereas binary numbers have base of 2. Next one, BCD. It is an abbreviation for binary coded decimal. BCD is a numeric code in which each digit of a decimal number is represented by a separate group of bits. Next, BCD adder. It is a circuit that adds two BCD digits and provides a sum digit also in BCD. Next one, binary. The number having base of 2 are called binary numbers. Next, binary code. The digital data is represented, stored and transmitted as groups of binary digits. The group of bits also known as binary code. Next one, binary decoder. A decoder which has an n-bit binary input code and one activated output out of 2 power n output code is called binary decoder. Next one, bit. It is a single binary digit. Next one, bus. It is a group of wires that transmit a binary word. Next one, canonical logical forms. The canonical logical form has standards of SOP and POS. If each term in SOP and POS forms contain all the literals, then these are known as canonical standard SOP and POS. Next one, character set. It is a group of characters used to represent specific value in any position number system. Next one, CLBs. The programmable logic block in the Xilinx family of FPGA are called configurable logic block. Next one, clocked flip-flop. Flip-flop which is allowed to respond to its excitation inputs only at the occurrence of clock pulse is called clocked flip-flop. Next one, code. A unique way to represent a number or character is called code. Next one, combinational logic. When logic gates are connected together to produce a specified output for certain specified combinations of input variables with no storage involved, the resulting circuit is called combinational logic. Next one, commutative laws. This states that the order in which the variables are ORed makes no difference in the output. That is, A plus B is equal to A, B plus A. And also AB is equal to BA. That is, the commutative law of multiplication states that the order in which the variables are ANDed makes no difference in the output. Next one, comparator. It is a special combinational circuit designed primarily to compare the relative magnitude of two binary numbers. Next one, counter. It is a register capable of counting the numbers of clock pulses arriving at its clock input. Next one, decimal to BCD encoder. The decimal to BCD encoder usually has 10 input lines and 4 output lines. The decoded decimal data acts as an input for decoder, and encoded BCD output is available on the 4 output lines. Next one, decoder. A decoder is a multiple input, multiple output logic circuit which converts coded inputs into coded outputs, where the input and output codes are different. The input code generally has fewer bits than the output code. Next one, De Morgan's theorem. The complement of a product is equal to the sum of the complements, and also the complement of a sum is equal to the product of the complements. Distributive law. A into B plus C is equal to AB plus AC. That is, the distributive law states that the OR several variables and AND in the result with a single variable is equivalent to AND the result with a single variable with each of the several variables and then ORing the products. Next one, don't care. In a logic circuit, when certain input conditions never occur, because of which the corresponding output never appears and it can be either high or low, which is called as don't care. Next one, duality theorem. The duality theorem says that starting with the Boolean relation, you can derive another Boolean relation by 1, changing each OR sign to an AND sign and changing each AND sign to an OR sign, complementing any 0 or 1 appearing in the expression. Next one, edge triggering. The term edge triggering means that the flip-flop changes state either at the positive edge or at the negative edge. The positive edge is also called as a rising edge and the negative edge is also called as a falling edge of the clock pulse and is sensitive to the inputs only at this transition of the clock. Next is EEPROM. It is an electrically erasable programmable read-only memory. The next one, encoder. An encoder is a digital circuit that performs the inverse operation of a decoder. An encoder has 2 to the power of n input lines and n output lines. In encoder, the output line generates the binary code corresponding to the input value. Next one, EEPROM. It is an erasable programmable read-only memory. It can be programmed by the user with a special EEPROM programmer. Next one, error detecting codes. The codes which allow only error detections are called error detecting code, and codes which allow error detection and corrections are called error detecting and correcting codes. Next one, XS3 code. XS3 code is a modified form of a BCD number. The XS3 codes can be derived from the natural BCD code by adding 3 to each coded number. For example, the decimal 12 can be represented in BCD as 00010010. Now, adding 3 to each digit, we get excess 3 code as 01000101. The next one, excitation table. A table that lists the required inputs for a given change of state. Such a table is known as an excitation table of the flip-flop. Next one, exclusive NOR gate. The term XNOR is a contraction of not XOR and not exclusive OR gate. It recognizes only the words that have an even numbers of ones and inputs having all zeros. This means that for even number of ones of the inputs or inputs having all zeros, the output of XNOR gate is high. Next one, exclusive OR gate. The exclusive XOR gate is an abbreviation for exclusive OR gate. They recognize only the words that have an odd numbers of ones. This means that the odd number of ones, the output of XOR is high. The next one is a fall time. The time required to change the voltage level from 90 degree to 10 is known as fall time. Fan out. The maximum number of inputs of several gates that can be derived by the output of a logic gate is decided by the parameter called fan out. Next one, flip-flop. It is a bistable 1-bit binary device which changes its state based on its excitation input. Next one is a full adder. The circuit which performs addition of 3 bits is called as full adder. And next one is a full subtractor. It is a combination circuit that performs a subtraction between 2 bits taking into account borrow of a lower significant state. Next one is a global or direct interconnect. Each input and output can be CLB as a particular local interconnect pattern called global or direct interconnect. Next one, gray code. It is a special case of unit distance code. In unit distance code, bit patterns for 2 consecutive numbers differ in only 1 bit position. These codes are called cyclic codes. Next one, off adder. The logic circuits which performs the addition of the 2 binary digits and produce a sum and a carry output is called a off adder. Next one, off subtractor. It is a combinational circuit that subtracts 2 bits and produce the difference. It is also an output to specify if a 1 has been borrowed. Next one, hexadecimal binary system. It has a base of 16 having 16 digits. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. It is another number system. It is particularly useful for human communication with the computer. Next one, hold time. It is the minimum time for which the voltage levels at the excitation inputs must remain constant after the triggering edge of the clock pulse in order for the level to be reliably clocked into the flip-flop. Next one, interdeterminate condition. When R and S sets inputs are both are high, the output is unpredictable. This is called interdeterminate condition. The next one, lockout condition. In a counter, if the next state of some unused state is again an unused state and if by change the counter happens to find itself in the unused state and never arrived at the used state, then the counter is said to be a lockout condition. Next one, logic gates. These are the basic elements that make up a digital system. The electronic gate is a circuit that is able to operate on a number of binary inputs in order to perform a particular logic function. Next one is a look ahead carry addition. It is the method of speeding up the process of addition of multiply bit numbers by eliminating interstage carry delays.